Welcome all to our S.A.E. Engineering College for the GATE course training. I am Ms.V.DIVYA PRABHA, Assistant Professor in EEE Department. Today we are going to see the topic regarding the single phase transformer. In that we are going to concentrate on the equivalent circuit. What is meant by transformer? First, basically we have to know the outline how we are going to draw the equivalent circuit, which is mainly we have to know about the single phase transformer, equivalent circuit, modes of operation, and then problem. These are the outline which I am going to teach today for the GATE course. So what is transformer? It is a static devices. As we all know, it transfers the electrical energy from one form to the another form without changing the frequency. Is it right? In that we will be having two windings, that is a primary winding and the secondary winding. In the primary winding, we will be representing the I1, V1 and E1, that is primary current, primary voltage and EMF, that is EMF in primary turns. And in the secondary side we will be mentioning as E2, secondary current and voltage. These are the terms. Other than that, we will be mentioning as flux linkage. This is the line which is known as a flux linkage. It is right. So while making the transformer in the equivalent circuit, we have to concentrate on mainly on the primary side and the secondary side. As well as in the gate concept, the primary side, which is referred as a primary and which is referred as a secondary. Why we have to go for the equivalent circuit? While we having the separate circuit for the primary side and secondary side, why we have to go for the equivalent circuit, which is used to simplify the circuit. For example, if you are having two major circuits, that is, if you are having all the turns, that if you are representing the primary side and secondary side separately, means we will be having the circuit will be very bigger side to represent. But here, while representing both the in same circuit, which is represented as the equivalent circuit. Okay, in that will be mainly concentrate on two modes of operations. One is no load condition and on load condition. What is meant by no load condition? No load condition, which will be represented as a I0, that is the load will not be given, which will be represented in the primary side. The primary side, the current which is I1, which will be represented as a I0. Here the I0, that is no load current. The no load current, which will be differentiated into two types, which is IW and IMU. What is IW and IMU? Which is known as a magnetizing current and core loss current. Okay, these are the two components which we have to know on it while referring to the secondary side. And while referring to the primary side, we have one more current which is known as a I2, which is the loaded current. Okay, here the secondary side will be loaded and the no load will be represented as a I0, which will be separated as IW and IMU. These are the main concepts which we have to know while representing the equivalent circuit. Okay. What are the terms? What are the terms which will be representing the first primary side alone? First one, R1, X1. R1 is resistance, primary resistance and reactance of primary side. And what is Z1? Which is the R1 plus Z1, X1 is which is known as a impedance, that is primary impedance. It is known as a primary impedance. And at the same side, in the secondary side, we'll be having R2 and X2, which is the secondary resistance and secondary reactance, which is known as a combination of resistance and reactance, which we have already known as impedance. This is the secondary impedance. And what is E1 and E2? Which is EMF induced in primary side, EMF induced in secondary side. While we considering the equivalent circuit, another point which we have to know is we are considering the transformer to be ideal condition, that is ideal transformer, and 1:1 transformer we have to consider. That means the primary side and secondary side windings will be equals, that is turns will be very much equal sides. If you are going for the step up or step down, the number of turns will be higher or lower, so the losses cannot be calculated, so it will be referred with the primary or either with the secondary. So in this concept we have to mainly concentrate as a ideal transformer has N1 and N2 will be equal. This is the second point we have to know it. First point which we have to know it is whether we are conditioning within no load or on load, and third point which is primary and secondary is considered as a ideal transformer. These are the components. And what is R0 and X0? It is the no load resistance and inductance which is produced by the magnetizing current and core loss current. These are the components which we have to know in this concept. So what is R1 and R2? Primary and secondary resistance. R1, R2, which is we have told already, R1 and R2 are the primary and secondary resistance. X1 and X2 is a leakage reactance. R0 and X0, which is exciting resistance. Exciting resistance is nothing but that is no load resistance and no load reactance. And what is I0? That is no load current. And what is IW? I have told already, it is a core loss and magnetizing current in the no load current. These are the two components mainly which we have to know for it. It will be used for developing the phasor diagram also. And what is I2 dash? I2 dash, which is referred in the primary side. Why we did not represent as I1 dash? Because this I2 dash which is formed due to the secondary involvement in the primary circuit. It is referred as a secondary current which is referred to the primary circuit. So it will be represented as a I2 dash. So what is I2? That is secondary current, and V1 is applied frequency, that is supply voltage, and V2 is the load voltage, and ZL is the load resistance, load impedance. So how to form the equivalent circuit? As we already seen the circuit, what are the conditions which we have been seen? On load, no load, and how the leakage fluxes are involved there. So first one, on the on load conditions, it is be represented as the on load condition, the I2 will be represented as. Already as I said, this I2 dash is the secondary oriented primary current, so it will be represented as a I2. And what is I0? Which is divided the magnetizing current and parallel and core loss. This both IW and IMU which will be presented parallel to the supply voltage. Always it is connected parallel to the supply voltage, because, and this is a mainly 1 mark question in the gate, which is V1, which is how it will be connected with the magnetizing and or no load current. It will be connected as a parallel. Okay, this is the main 1 mark question which is asked in the gate exams. And what are the next points we have to remember it? The primary and the secondary windings have the finite resistance. Finite resistance means which will be calculated. Okay, this to be handled with that. And second point, the flux leakages or modeled as a leakage reactance. The core loss which is connected as a shunt. Shunt is nothing but the parallel connections. The magnetization of the core model used a magnetizing current, that is magnetizing the magnetization core which is connected as a parallel. This is the main thing. This should be connected, should be connected parallel to the magnetizing current and the voltages, core voltages. So what are the key points which you have to remember while converting the equivalent circuit? So first point, the transferring resistance or reactance. While we are transferring resistance from primary to secondary, that is primary to secondary, while we are converting the current or the resistance or reactance, that is R1 or X1, R2 or X2, we have to multiply by K square. What is K? It is a number of turns ratio. It is a number of turns ratio which is referred as K. And while transferring the resistance or reactance from secondary to primary, while R2 to primary, while we are connecting it, we have to divide it by K square. And third point which we have to remember, while transferring voltage or current from one winding to another winding, we have to use K, either by multiplying or dividing. From primary to secondary, you will be multiplying with K, and while transferring from secondary to primary, we have to divide it by K. This is the main concept which we have to remember while solving the problems in the gate or normal. So these are the main formulas which we have to remember it. For first one, E1, which is referred as a induced EMF on the primary side, while we are converting into E2 dash, that is we are referred to the primary side, which will be mentioned as E2 dash, which is the formula already we have been told. The induced EMF or something voltage or current should be divided by K or multiplied by K. Here it is referred to the primary, so we are dividing by K. Okay, so next one, voltage, which is secondary voltage, which is referred to the primary, so we are dividing by V2 by K. And what is I2 dash? It is a current, secondary current, which is represented in the primary side, which is calculated as K into I2. And next one, impedance, reactance. So X2 dash, which is equal to X2 divided by K square, and resistance, which is divided by K square. Do you remember? This is the point, which resistance and reactance should be divided by K square, where secondary to primary. So has of X2 divided by K square and R2 dash divided by K square. And while referred to the secondary, what is the point we have to remember? We have to multiply by K and K square, is it right? So while transferring, E1 dash is equal to E2, which is equal to K into E1, and while transferring with the primary voltage, K is into V1, I1 dash, which is equal to I1 divided by K, X1 dash is equal to K to X1, R1 is equal to K square R1. So what is the formula for I2 dash, which is I2 divided by K square. Okay, this is the remembrance. If you are referring I2 dash here, I1 dash, here it will be I1 dash. So it will be multiplied by K. I1 divided by K. So next one, at the no load condition, what are the points we have to remember it? So while making the problem, we are having the IW, which is the copper loss, correct? Sorry, that is core loss. The core loss which is equal to I naught cos phi naught. And magnetizing component, which is referred as a I mu, and it is referred with the sin phi. And no load current, which is no load current is the combination of core loss and magnetizing current. So IW plus J I mu. What is primary factor at no load? Which is cos phi divided by, if you are going to find any angles in the equivalent circuit which will be used in the phasor diagram, it will be mentioned as IW divided by I naught. If it is a load power, we already know P is equal to V into I. Always it is a DC or AC circuit. It is an AC circuit, so it will be having cos phi. Angle will be differed, so it will be having cos phi naught. What is existing current? That is R naught. R naught is R is equal to V by I. V by I, but here we are mentioning as a no load current. So no load current means here it will be mentioned as a working component, that is core component, core loss component, V1 divided by IW. Next one, exciting resistance, which is X naught is equal to V1 divided by I mu. So next we are going for the problem. Okay, if an ideal transformer has an inductive load, so here the ideal transformer is n:1 ratio, which is have the inductive load, that is L load. Element has a port 2 in the port 2 part, that is in secondary part, has shown in the figure below. The equivalent inductance at a port is. So what is the port 1 equivalent value? This is the question which we have to solve. So what is the concept over here? It is has given us n:1, that is the ratio which is n:1. So while giving the ratio, and it is a inductive load, what is the transformer ratio formula? While mentioning as a terms n2 divided by 1. So what is the ratio? 1:n:1. So it is a n1 and this is a n2. So while mentioning as n2 is equal to 1, n1 is equal to n. Since it is a inductive load, so what when the port 1 is referred to the inductive load, what is here mainly mentioned as port 2 is secondary and port 1 is primary. So port 1 while mentioning as inductance, it will be divided by K square. As we all know, it will be divided by K square. Is it right? Inductance, resistance and inductance which will be having the same. So R2 divided by K2, K square. So same concept here. So L divided by K square. What is K? Already we have been found it as 1 divided by N. While substituting here 1 divided by N square. So what is the answer? N square L. So what is the equivalent inductance for the port 1 is N square L. So let us move on to the second problem. If a 2200 bar 220 volt 60 hertz single phase transformer has primary and secondary resistance of 100 ohms and 10 ohms respectively, then the value of the equivalent resistance of the transformer is referred to the primary side and the secondary side are. What is the concept over here? They have been mentioned as how to find the equivalent resistance value. Is it right? While considering the primary side has a referred value and secondary has a referred value. Over here, what are the given data over here? Which is V1 and V2. Is it right? 2200 is V1 and 220 volt is V2 and 60 hertz is frequency. And what are the resistance? Next one, given points are R1 and R2. These are the given data. How we can find? As usual, we have to consider as a ideal transformer, and ideal transformer means we have to mention as a number of turns. Here we have voltage, we don't have number of turns, right? If you don't have number of turns, what is the next formula we have to remember is V1 divided by V2. So V1 what is 2200 which is given, and V2 is 2210. So while cancelling we will be having turns ratio will be 10. Okay, what is it equivalent circuit referred to the resistance? So I will be finding R01. What is R01? It is referred to the primary second resistance. As we already know, R1 is what is R1? It is a primary resistance, right? It is a primary resistance, and R2 is secondary resistance. While converting the R1 and R2, what we have been done with it? R2 dash is equal to R2 divided by K square. Is it right? And R1, that is while confirming with the secondary side, R1 dash is equal to K square R1. So here while referring with the R01, R01 which is equal to R1 plus K square into R2. And while referring with the secondary side, R2 plus R1 divided by K square. It is with the secondary, this is with the primary side. So just we have to substitute the values over here. So R1, to find the R01, will be having the total resistance, that is the equivalent resistance. R01 which is referred to the second primary side. What is R1? 100 ohms. And what is the turns ratio? 10 square. What is the R2? 10 ohms. While substituting it, will be get as a 1100 ohms. And second one, while referring to the secondary side, what is R02? It is an equivalent resistance, that is total resistance present in the secondary side by referred in the primary side by comparing with the secondary side, refer to the secondary side, which is R2 plus R1 divided by K square. What is R2? Here 10. What is R1 here? 1000 divided by 10, which will be getting as 11 ohms. Thank you. We will be seeing in the next sections.